In this video, we are going to learn about the operations of basic gates. Now the basic gates, what are the main basic gates? So I have already, you can see on the screen, the various kinds of basic gates are, this is AND gate, this is NOT gate, it is also called as an inverter, it is also called as inverter, and this is OR gate. So basically these three gates are called as basic gates. Now let us see the truth table and verification of each and every gate. Now first let us focus AND. AND ka equation, Boolean equation is expressed as y is equal to a into b. That means the output of AND gate is equal to product of the input variables. Here a and b are input variables, a and b, and y is output variable. Now let us first verify. I have used two toggle switches over here, A and B. So let me click first the first switch. So I make this one switch as 1. You can see the line has turned blue over here. That means this input is now 1 and this input is 0. Now the product of 1 into 0 will be equal to 0. So that is how it is shown with the light, that the bulb here is off. I hope this is clear. Now we'll see the next case. I'll just click on this switch. I will turn the B switch also on. Now my B switch is on and we can see that the bulb is on over here. So let me clear this, and the input over here is again logic 1. Now here A is also 1 and B is also equal to 1. So 1 into 1, that will be equal to 1. Therefore the bulb is now showing on. So here on we are considering it as logic 1 and off we are considering it as logic 0. So this is the basic operation of AND gate. I hope AND gate concept is clear. Now let us see the next gate, that is OR gate. Now here I have shown you the OR gate. The logical operation of OR gate, or the equation for the OR gate, can be given as y is equal to a plus b. Now let us verify this. Now initially this is A input, B input, and this is Y output. So OR gate gives you sum of input. OR gate gives you sum of inputs. Now initially both the inputs are 0. So summation of 0 plus 0 is 0. Therefore the bulb is off over here. As I told you, off it can be considered as 0. Okay. Now we'll consider the second case. I will take A as 1. I'll just double click on this. Now this input has become 1. So write here as A is equal to 1, B is equal to 0. Now A is equal to 1 and B is equal to 0. The equation becomes 1 plus 0, and that we can show it here as 1 plus 0 is equal to 1. Now therefore, since this is 1, now the bulb is shown over here is on. Let us consider the next case. Let me clear the screen. Now in the next case, what we'll do is we'll take B equal to 1 and A equal to 0. So let me change the input. A equal to 0 and B equal to 1. So now what I'll do is I will turn off this switch and I'll turn on this switch. Now see, B is equal to 1. Again what we are getting here, output as the bulb is on, and on we consider as 1. Equation y is equal to A plus B. Here A is 0, B is 1, therefore y is equal to 1. So y is 1, therefore output is 1. The last case, okay. In the next case, what we'll do, we'll take both A and B input as 1 1. So I'll take A as 1 and B also as 1. So let me turn the switch for A also on. Now our equation is y is equal to A plus B 1 plus 1. Here 1 is not the arithmetic one, remember it is not a number. Here 1 means high input or high voltage. So 1 plus 1, it will not be equal to 1. It is not equal to 2. It is 1. Okay. And this one can be considered as on. Therefore, the bulb is on. So this is how we have verified the truth table for OR gate. This is OR, this is AND. Let us see the last one. Let me clear all drawing. Now this is a NOT gate. Okay. NOT gate is very simple. It has only one input A and one output Y. So when I say A is equation for NOT gate, Y is equal to A ka complement or inversion of Y. That means if A is 0, Y is equal to 1. Second case क्या हो सकता है? If A is equal to 1, Y should be equal to 0. Means whatever input I am giving over here, output will be complement of the input. Now let me see. I'm going to give here A is 0, therefore the bulb is on. So we can say the output is high. So here we can say that bulb is on. Now let me change the input for NOT gate. Let me clear the drawing. So now I'm making A equal to 1. Now you can see that the bulb is off. So that means when A input is 1, output is 0. And therefore the bulb is off in this case. So this is how we have verified the truth table for NOR gate. So this is how all the basic gates work. So to summarize the things, basically there are three basic gates. The basic gates are AND gate, which give products of input. Second is OR gate, which is summation of input. And third is NOT gate. It gives the complement of input. Equation for AND is y is equal to A multiplied by B, where A and B are the input and y is the output. Equation of OR is y is equal to A plus B, A input, B input, y is the output. Equation of NOT is y is equal to A ka complement. So A is the input, y is the output. So as a summary, we can write down the truth table as for AND gate 0 0 0 1 1 0 1 1. So in this case, y will be equal to product is 0, product is 0, product is 0, and product is 1. Now for OR gate 0 0, output is 1, 0 1, 1 0, 1 1. So summation is 0, summation 1, and summation. And for NOT gate, when A is 0, output is 1, when A is 1, output is 0. This is how we have verified the truth table for the basic gates. Thank you very much for your time and attention. I hope the truth table and the logical equations of basic gates is now clear to you.